Okay, another video here. Gonna do a bleeds off takeoff today, Chicago 3-1 center. Simulate essentially a hot day, long flight, lots of gas, heavy jet, and doing a bleeds off takeoff to get maximum performance, maximum thrust out of the engines to essentially reduce our takeoff roll and enhance climb performance, etc. Let's read real quick in the AOM here. We got engine bleeds off takeoff. Use following procedure when making an engine bleeds off takeoff with the APU operating. Use this procedure to increase ATOG, increase initial climb performance, or improve runway stopping margin with the APU operating. Take a quick peek at the air panel here. The procedure itself says right pack switch in auto, isolation valve switch closed, left pack switch in auto or high, left engine bleed air switch off, APU bleed air switch on, and right engine bleed switch off. It does have a note here, and that's why I've got this configured this way. We just got off the gate, we're taxiing out to the runway, we want to keep the passengers cool. The note here says the right bleed switch may be left on prior to completing the before takeoff checklist to allow better cabin air conditioning. Just a real quick refresher here before we take off. What the next procedure here would be reconfiguring following a bleeds off or unpressurized takeoff at or above minimum cleanup altitude. Complete the following. Pilot monitoring. If it bleeds off or unpressurized takeoff is performed, reconfigure the packs and bleeds. For a bleeds off takeoff at not less than minimum cleanup altitude after the flaps are up at climb thrust, perform the following steps. Follow each step, note the appropriate pressure indication change before continuing. The pressure, of course, being the duct pressure. Right engine bleed air switch would come on. If engine failure occurs, do not position engine bleed air switches on until clear of obstacles. Captain, if the pressurization panel is beyond reach, assume aircraft control and direct the first officer to reconfigure the system. Following an unpressurized takeoff, plan to begin reconfiguring the aircraft pressurization panel prior to 2,000 feet above airport elevation. So we would have the right engine bleed air switch back on at this point. When cabin rate of climb indicator stabilizes, which of course we're talking about this cabin rate of climb indicator here, APU bleed air switch off. As I said, you're going to go slow. So on. Watch that pressure rise. Left duct pressure with APU off. Watch that left duct pressure drop. Left engine bleed air switch on. Isolation valve switch auto. Here it says captain, APU off as required. The APU has built-in cooling circuitry and may be switched off without delay. Pilot monitoring, verify the aircraft is cleaned up and pressurizing properly. So you're going to want to double check your pressurization gauges here. Make sure you got a little bit of cabin climb, maybe no more than about 500 foot per minute, and you start to get a little bit of the split between the two needles here. The outermost long needle, of course, being the differential pressure in PSI between the outside of the aircraft and the inside of the aircraft, and the little needle on the inside indicating cabin altitude. So if you're at 1,200 feet, when you perform this procedure, this needle is going to be right over here at 1,200 feet and should essentially hold there while the cabin starts to pressurize, and then you'll start to see the differential rise, and the cabin pressure will probably stay about the same spot. Hopefully we think about that. We'll take a look back up here and try to see what that's all doing. The best way to remember this procedure as you go to reconfigure is literally a reverse C. So the way to set it up, you can think of squeeze, so those two are together, spread, those two are apart, squeeze, those two are together. Again, we're going to leave this on until just before takeoff so we get airflow. And then your reconfiguring process is pretty much a reverse C. So start here, you're going to bring this on, APU off, left engine bleed on, auto, auto, auto. It's pretty simple to reconfigure. You just kind of got to take your time in doing it to make sure that you don't backflow the duct pressure through the gauges, or through the ducts, through the lines there between you know, the duct lines there. All right, so let's take a look at the jet itself. Pretty well set up. Midway 3-1 center is the longest runway, so typically this happens there. Now, obviously, if the winds favor 2-2, that would be the case. More than likely, PWB is going to kick back at least a flaps 25 takeoff, seeing as that's your maximum takeoff flap setting. It's going to try and do everything that it can to get you a bleeds off takeoff. It's going to look at every flap setting, and then the last resort, last resort, it's going to give you a flaps 25 bleeds off takeoff. So that's what we'll simulate today here. And as I said, you know, likely what's going to happen here is you're going to be pretty heavy. Lots of gas. We're showing almost 27,000 pounds of gas. We're going a long ways. And a hot day. Perhaps it's, you know, in the upper 80s, low 90s, maybe even approaching 100 degrees in Chicago if you're going to have to do something like this. So, got the jet pretty well set up. Do a quick check here. Parking brake, we'll drop that, do a throttle burst, make sure we don't have a takeoff warning horn. Armor auto throttles, a little captain flow here. Fuel is verified. One ding for the flight attendants. Fuel is verified. We've got our takeoff fuel. Before takeoff checklist, departure plan is not required. Attendant notification complete. Electrical generators. Still using the engine generators in this case. We just want to make sure the APU is on so that we've got the APU for the air. Electrical generators are on. Anti-ice is off. Packs are auto. Bleeds. Engines off. APU on. APU is on. Flaps. Start switch is left continuous. APU is on. Flaps. We got CDU 25. Indicates 25 with the green light. Start levers are idle. And recall checked. For takeoff checklist complete. We're cleared for takeoff. Towers cleared us for takeoff. Clear left, clear right. Runway 31 center is verified. And the before takeoff checklist is complete. Pretty standard takeoff, except we got flaps 25. As I said, at min cleanup altitude, once the jet's clean, we'll reconfigure the air conditioning panel. And you also see the flap reconfiguration sequence here as we depart. This would be a max takeoff, thrust takeoff. There's not going to be any thrust reduction in this, of course. I believe that's probably the overwing doors that you usually get with a little bit of a glitch there. 80 knots.
80 knots.
E1, rotate. Landing gear up. Positive landing gear up.
Positive rate of climb.
We also spun in at 250 heading off 31 center. You typically do get about a 250 heading out of Chicago. That exactly coming left to 250. Going to 3,000. Alright, set speed. Flaps 15. Climb thrust. Two for 3. Past the 5 bug, we'll go flaps to 5. Past the 5 bug, flaps to 1. And past the 1 bug, flaps up, leveling 3,000. We'll go ahead and put the autopilot on. Make sure everything's looking good here. We'll go ahead and roll the window up to 250. Midway 6 is 250 until advised, so make sure you leave the window open there at 250 until you're allowed to go faster. Clean jet, clean up, here we go. Captain's going to bring those lights off as usual. And you as the FO have brought the auto brakes back to off. Landing gear lever handle is off. And here you go. Here's your reverse C for your cleanup. Now you can see cabin differential pressure is at about 1 psi. Cabin altitude is just under 1,000 feet. No climb, no descent, but we're level. So let's do the reverse C. On. Engine on. Watch that duct pressure rise. This is isolated, so we're not too worried. We can go APU off immediately. Watch that duct pressure. Let it go down to almost zero before you bring the left engine on. Duct pressure from the left side, but the engine on now starts to rise. Pack is auto, auto, auto. You're reconfigured. That's it. You might even be able to see at this point. Watch some of this magic start to happen. In fact, what we can do is we can go ahead and initiate that climb. We'll go 10,000 feet here. Altitude intervention. Let the VNAV take over. Watch the power come up, starts to climb. Our speed window's open, 250 knots. Start making our climb up. Make sure we don't overspeed. I'm going to pull this back a little bit and let her go. The old PMDG, come on. Alright, let's check out this pressurization again. So now we got a little bit of a cabin climb going on, that's great. We're pressurizing normally. So our cabin pressure, cabin altitude's holding pretty steady at just under 1,000 feet while the differential is rising. The cabin is climbing. So you'll watch that little needle start to rise, but the point is here we've got this panel reconfigured, engine bleeds are on, APU is off, we're in auto, auto, auto. Last step, let's not forget, now at this point we don't need the APU anymore, we can turn that off. Alright, that's about it.